Hello, this is Module 5 Investigation 4 about quadratic functions. So we already graphing the quadratic function which was comes out as a parabola. So as a quadratic function, the general forms of the quadratic function is a function is always ax squared plus bx plus c. So as long as you get the ax squared and then the bx plus c is, you might see or you might not see it, but as long as you have an ax square, we call the quadratic function. So if you look at the a b c d e, and then those are functions that we call the quadratic function because x has a degree of 2. But number one, we are using the graphing calculator to actually sketch the graph to the following quadratic function, and then we're going to compare the behavior and then property of this function. Also, we want to determine the roots, which means the x-intercepts. Okay, so let's look at the Desmos for this one. Okay, so let me use the Desmos. Okay, so all right, so I'm gonna actually the graphing the functions here. So first function is a function. So I'll say f of x equal to the x squared, which is that's the basic function of the quadratic function. So as you notice, do you see the blue graph, blue parabola? It is an x squared function graph. On here, the x-intercept is only the x equal to 0 here. Okay, so let's get the second one, which is a g function. So g of x equal to the 3x squared. So we'll see the difference. So the blue graph represent to the 3x square functions. Okay, so what's the difference between the red and blue? Blue function is a little narrower than the red graph, right? Because this actually the when we have x values here, right? Well, when we have x square was the when x equal to 1, and then the y is equal to 1, right? But if you have a 3x square when x equal to 1, and then y is come out as actually the 3. So it's been the stretching 3 times. Let's get to the 1. Okay. Yeah. So same x equal to 1, but y value for the x squared come out as 1, but the g function come out as a 3. So 3 times more than the g function has a 3 times more than the f functions. Okay, and then the third function is the h function equal to h function is 3x squared and minus 27. So h function in here is going to be the green graphs. So the green graphs, which is y-7 is all the way to down here. But oh, so I forgot about the roots. Okay, so the root of the red function was 0, and the root of the g function was blue function is a 0. But root of the h function, this is 3x squared minus 27, there's a 2x-intercept here. So one is x equal to negative 3, and the other one is x equal to positive 3. Okay, so those are the roots. And then the next one, I'm gonna graphing the k function. So k of x equal to the negative 3, parenthesis x minus 7, and close parenthesis and square. So the purple graph represented this one. So purple graph is going to be upside down because of negative is a 3, right? And then also stretching the 3 times vertically too. And then for the roots, it's going to be x equal to 7. Okay, so last function will be the p functions. Go to the parentheses. So 2x minus 9 times x plus 4. So the blue graph actually represent the p function, black graph, sorry. And then for the x-intercept, so it should be this one, which is -4, and then the root, another root is going to be the 4.5. So if you use the decimals, you can easily graphing the quadratic function. Actually, the any functions, okay? All right, let's go back to our original problem, okay? So let's do number 2. But also, without actually using the graphs, we can still find the roots. So easier way to find the roots. So root means actually when they say it, the function is equal to 0, okay? So 0 equal to x squared. And then you can just solve for x. So since it's square root both sides, square always takes it plus minus. So but 0 has only the 0. Okay? 0 is only the 0. So x equal to 0 this side. For the b function, so g of x equal to 0, 3x squared divided by 3, you still get 0 equal to x squared. So same as that function, square root both sides. Then you got 0 equal to dx. So only one solution, which is one root. Set as h of x equal to 0. And then add 27 both sides. 27 equal to 3x squared. And divide by 3 both sides. You got 9 equal to x squared. And square root both sides. But 9 has a plus minus as a 3. So you got two solutions for this one. Set the k of x equal to 0. Negative 3 of x minus 7 squared. Divided by negative 3 both sides, which is a 0 equal to x minus 7 squared. And then cancel the square with the square root, which is a 0 is a 0. You got x minus 7, add 7 both sides. 7 is x. That's the solution. For the b of x function, set the 0 of 2x minus 9 of x plus 4. But I need to introduce the 0 product, the property. Which means if you have a times b, which is a is one of the factor of the product and b is another factor of the product. But one of the factor becomes a 0 and then your product always becomes a 0. So which means 2x minus 9 is one of the factor. So set equal to 0. X plus 4 is another factor. So solve for x. So add 9 both sides. 2x equal to 9 divided by 2. So x equal to 9 over 2, which is 4.5. For the other one, subtract 4 both sides, x equal to -4. So this one has 2 solutions. All right, let's go to number 2. In number 2, use your graph from the exercise 1 to answer the following questions. So when a quadratic function f is given, it's a factor form. Okay, so factor form means you just have a factor to get as a product out. Explain why the roots x-intercept occurs where each factor has a value of the 0. Because the value of the f of x at each root is a 0, so in the factor form, the roots occur where each factor has a value of the 0 because the 0 product property. So when we say root, always f of x equal to 0. Okay. And then you just need to set each factor equal to 0 for the 0 product property, okay? And then solve for x. So add 3. So x is 3 is one of the solution. Subtract 4. And then -4 is another solution too. B. Is it possible for the quadratic function to have a positive concavity over the one interval of the domain? and negative concavity over the some other interval of the domain? I want to say no, because the quadratic function is always the parabola, which is going up or going down. So this one is we call the positive concavity. And then the second one is a negative concavity. So the parabola only going to have a positive concavity or negative concavity. So you can get a both. Okay, so it's not possible. So if you have a positive concavity and negative concavity, that's not going to be the quadratic function. See, does a quadratic function always have a maximum values? Not really, because when you have a parabola, so when you have a downward parabola, vortex will always give us a maximum place. So this is the highest place, that's why you're getting a maximum. But when you have an upward parabola, which is the lowest place, the vertex, so this one gives us a minimum. So you sometimes you have a maximums and sometimes you have a minimum at the vertex. D. How do you determine if the quadratic function will have a positive or negative concavity? For the as a graph, and you can see it. So do you see the going up or down, right? I will talk about that, right? Yeah. As a table, you just need to fill the table. So if you use the number here, -2, -1, 0, 1, and 2, and then if it's concave upward, which is a positive concavity, gonna be the 4, 1, 0, 1, 4, which is when you from the 0, from the vertex, equals a positive infinity and equals a positive infinity. That's a concave upward. If you have another one has -2, -1, 0, 1, 2, but this one has a -4, -1, 0, -1, -4. So from the 0 from the vertex, it goes to negative infinity, and the other side is also negative infinity, right? So that one we call the negative concavity. And also the formula for the quadratic functions, which is f of x equal to a times x minus h squared plus k, or f of x equal to x squared plus bx plus c. So in here, how do you know that the concave, the positive or negative? It's up to a. So a is a positive, always concave upward. A is a negative, is always concave downward. E. What is the relationship between the x coordinates where the maximum minimum function value occurs the function's roots? So since the quadratic function have a line of the symmetry that passes through the vertex, and the roots of the function must be the equidistance from the x coordinates of the vertex. So what you mean is when you have a plane, and then when you have actually the parabola, and then there's a line of the vertex here, so which is this. So this line is we call the x over h. And then the two roots on the x-axis always equidistance. This distance same as this, and this is same as this. So if you know the vertex, and then one of the roots you know, the other roots easy to find it because you just need to go the same distance from the symmetric line to the another of the x-intercept. Okay. Alrighty. Okay. Let's go to the quadratic formula. So if you in order to solving the quadratic equation, okay, so this is the formula for the quadratic equations, okay, so which is x equal to negative b plus minus square root of b squared minus 4ac over 2a. So this one usually they write as negative b plus minus square root of b squared minus 4ac over 2a, and then they just split that amount because on here. So when we do the number 5, what does the x negative b over 2a represent? Actually, when you have a function as a quadratic, which is a standard form, you can always switch to the vertex form, which is vertex is h and k. So h is x and k is y for the special point of the quadratic we call vertex. But h is always going to be negative b over 2a. And then in order to find the k, you plug in the h in the function, which is your h is a negative b over 2a. So what does the x equal to negative b over 2a represent? is going to be the x coordinate of the vertex. And then b, what does f of negative b over 2a, which is going to be the y coordinate of the vertex. And then what does the plus minus square root of b squared minus 4ac over 2a represent? So that was actually the distance from the line of symmetry to each root values, which is x innocent. Okay, then what does the mean as square root of b squared minus 4ac over 2a equal to 0? So for the sum quadratic function f, what does this tell you us about the functions? So that means actually you don't have any distance from the roots to the line of the symmetry, okay? So which means the vertex is a root. So x coordinates, sorry. So which means x coordinate of the vertex is root. Okay, and then assume that for a given quadratic function f, the solution to the quadratic formula are the x equal to negative 4 plus minus 3.25. Create the possible sketch of this quadratic function and illustrate the vertex and roots of the quadratic functions. So the negative 4 is represented by negative b over 2a, and then plus minus is represented by the plus minus square root of b squared minus 4ac over 2a, okay? So which means this gives us actually the roots, okay? So one root is negative 4 plus 3.25. Another root is negative 4 minus 3.25. So negative 4 plus 3.25, it's going to be the negative 0.75, and the other one is negative 7.25. So if I need to grab this on the plane we have here, so if I put it in, so negative value, so I might want to axis the axis come out this way. So this is x-axis, x-axis, and this is the y-axis, okay? So the negative 0.75 is about here, and then negative 1, 2, 3, 4, 5, 6, 7.25 is about here. So these are the roots, which means and then the h is negative 4, which is same as vertical line, right? So negative 1, 2, 3, 4. So you get the line of symmetry. So this equal to the negative 4, which means your vertex is right on here. Okay? Oh, sorry. Your vertex is right on there. So what does that mean? Your vertex is right on here. So what does that mean? You can have any of the vertex, maybe here, and then it goes this way, which is a downward parabola, right? And then what if you have a vertex here? It goes up. We're going to the roots, okay. What if you have a vertex right here? Yep, but it goes through the roots. And then it goes through the roots. Okay, so there are different cases of the parabolas we can get. Okay, all right. Thank you for listening.